Hi, I'm Don the Coder, and today we're going to write a program that codes or encrypts messages so you can send secret messages to your friends. This is the way it'll work. You run the program, you enter a message, and it will give you a encrypted version of the message. Now you copy that, you send it to your friend, and your friend then puts it in the program, pastes it in, and gets your original message. So let's see how we do that. Now I'm using the PyCharm editor on a MacBook. You can use anything that's convenient for you. That's a nice thing about Python. You can run it pretty much anywhere. So we're going to create a file, and I'm going to call it code1 because in later videos we will make it better. So let's start coding. And the first thing to do is always to write comments. So comments are important to let you know what your program does, especially if you look at it a year or 2 years from now. You'll know what it was. And we're going to just start with the program name, code1.py, and then what it does. It encrypts secret messages. Now the messages are special because they are reversible. If you enter the encrypted message back into the program, it displays the original message. Okay, now let's start coding. Now the most important part of coding is not actually coding, it's thinking. So let's think about how this program should work at a very high level. So the first thing is it should read in a message. And we're going to just make a comment here, read in a message. The next thing it's going to do, it's going to encrypt the message. Encrypt the message, and then finally it's going to print the result. So having it in as comments like this, we can look at it and say, yeah, this is exactly what this program does. We read in a message, encrypt the message, and print the result. So let's save this program now, because we should save often. It's a very important habit to get into. And let's start turning this into real code. So read in a message. I always like to print a blank line before I ask for input. It just makes things look neater. And then we use the input statement to get our message. Message equals input, and our prompt will just say enter message. And that's it. Now everything we do we should test. And it's important to test early, test often. So we read our message in just to make sure it's right. Let's print our message out again. Let's save this program. We can actually run it. And let me move this up here. There we go. Enter message. Hello, Mom. Okay. And it printed out hello, Mom. So far, it's doing exactly what it should. We know at this point our program is correct. Now we need to encrypt the message. We're not quite sure how to do that yet, so we're just going to say result equals, and we'll say it's an encrypted message. And then finally we'll print the result. Again, I like to print a blank line, and then we'll print, and we'll say result and our result. Save that, run that, enter our message, pizza tonight. Result encrypted message. Well, okay, so it does exactly what we expected it to do. So we know at this point this program is correct. Now we need to fix it to actually make it encrypt something. And how do we encrypt a message? Well, there's lots of ways to do it, and we should start with something easy. It's always important to start with something very easy, and you can make it more complicated later. In fact, we're going to do that in another video. We'll make this more interesting and more complicated. But to start with, we'll use what's called a simple substitution code. We'll take every letter in the message and change it to a different letter. So to do that, we first need to look at every letter in the message. And how do we do that? A string, like our message, works a lot like a list in Python. So you can use subscripts to find individual letters, or you can use the for statement to get all of the letters one at a time. And that's what we're going to do. We're just going to say for letter in message. And what we will just do here is we will test things. And remember, you have to indent inside a for loop. Your editor will probably do it for you. If not, just space over 4 spaces is the convention. So let's print the letter. And then let's add that letter to our result. So we could say result equals result plus letter. And that's actually going to give us just the letter back again, the original message. We need to initialize our result first. We'll say it's an empty string. Okay, we'll get every letter, print it out, and then print the result. Save this, run it, and enter a message, my message. Okay, so it printed out individual letters, so we can see that we are in fact breaking our message into letters, and it printed the result, which is not very interesting at this point because we haven't coded anything yet. So we've got each letter. What are we going to do with each letter then? We're going to code them using a substitution code. And let's think about how we could do that. Let's just write some comments here for ourselves. We're going to replace each letter with something else. We could, for example, replace each letter with the next letter in the alphabet. We could turn A into B. We can turn B into C, etc. Now, if we do that, if we have a message ABC, we'll turn it into BCD, which is coded. It's not really obvious what the message is, but it doesn't meet our requirement that the message should be reversible, because if we entered BCD and did the same thing, we would get CDE, which is not the same as ABC, so it's not what we need. So what will we do instead? Here's something very easy and clever, is that we will replace each letter with the equivalent letter at the reversed position in the alphabet. So A will become Z, B will become Y, and C will become X. Now our message ABC is going to turn into Z, Y, X. And if we put ZYX back into the program, ZYX, let's see, Z goes back to A, Y goes back to B, and X goes back to C. So we get the correct message back. Our code is reversible. Okay, so how are we going to do that? For each letter, first we have to find its position in the alphabet, like A is position 1. Now, strings, like lists, always start with position 0 in Python. So if we had our alphabet, A would be position 0 in the alphabet, B would be 1, C would be 2, etc. We need an alphabet for reference here, so let's just add one. We'll say alphabet equals, and let's type A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So we should try to type it correctly. If we don't get it right, actually, interesting point is if we don't get it right, it'll still work, and we're going to see that in the next video. But for now, we're going to try to get the alphabet in the correct position. So now we want to find the position of each letter as we look at each letter. And For letter in message, we'll say position equals alphabet, and we'll use this function in Python called find, which finds a smaller string inside a larger one. And in this case, the smaller string is just one letter, and this will give us a number. So here in this print statement, we're going to, again, see what our answer is. We're going to print the letter and our position. Let's save the program, let's run it, and let's just say ABCD is our, well, let's say alphabet is our message. Whoops, look what happened here. A is 0, that's correct, it's the first letter in the alphabet, but for the other letters it gave us a -1. Well, what does that mean? Well, in the find statement, if it can't find the thing it's looking for, it returns -1 as the position. And why can't it find these things? Because we used lowercase letters rather than capitalized or uppercase letters. There's a lot of ways to get around that. Let's do the simplest. Let's just turn our message into uppercase, because that'll be fine. And we'll say, instead of letter in message, we'll say letter in message dot upper. So dot upper converts a string to uppercase or capital letters. Dot lower would convert a string to lowercase or small letters. And now let's see if this works. Save it, run it, and we're going to do the same thing, alphabet. Oh, we got numbers now. A is 0, which is what we expected. B is 1, which is what we expected. It's the second letter or the first subscript. T is the furthest in the alphabet that we've used. It's 19. That sounds about right. So far, so good. So we have the position. Now we have to find the position at the other end of the alphabet and convert the letter to a new letter. Let's say new letter equals alphabet. If we said alphabet dot subposition, it would be exactly the same as what we started with. Python is a really nice feature in that you can look at lists or strings from the back, and we can say minus position. Let's see how that works. So -1 will be Z, -2 would be Y, and so forth. So let's, do you have your thinking cap on? We're going to see a problem. Can you guess what it's going to be? Okay, let's just type A, B, C, D as our message. Well, A is 0, B is 1, C is 2, D is 3. Oh, we know that works. We forgot to print out our new letter. So let's move this print statement down. We'll print letter, position, and new letter. And we'll add new letter to our result rather than letter. Okay. Save it, run it, and A, B, C, D. Okay. We got A, 0, whoops, it changed A to A. That's not right. It changed B to Z. We want A to turn into Z and B to turn into Y. Why did that happen? Well, take a look at this. If we're counting backwards, the last letter here, Z, is -1. But A is 0. So if we do -0, it just gives us 0 again, which gives us A again. So what we need to do is we need to subtract another 1 from our position. Let's see if that works. I'll run this, and we'll do A, B, C, D again. And this time it works. It gives us Z for A, B for Y, C for X, which is exactly what we wanted. Okay, so we can take this temporary print statement out, and I believe our program's nearly done. So let's run it and see. Let's give it a bigger message. My name is Snoopy. What did it do? It gave us it turned these blanks into A's. So that'll be M-Y-A. That isn't going to work very well because it's not backwards. Why does it do that? Again, just like the lowercase letters, if it didn't find anything, it gave us a -1. Then if we did the alphabet position -1, well, that turned into 0 and it gave us an A. So we have to do something else. We have to check first whether the position is a -1. And we could do that several ways. We can use a regular if statement, say, if position is greater than equals 0, else do something else. But there's an easier thing to do. It's my favorite statement in Python is the trailing if. We can say new letter equals alphabet minus position -1 if position is greater, well, this thing's given us suggestions that aren't always great. If position is greater than equals 0, because 0 is valid. Then we can say else. What will we set new letter equal? We'll set it just equal to letter. Okay. Save that, see if it runs. And now we can say, my name is Inigo Jones. Up, now we have spaces in the right place. Now we need to see if it's reversible. Let's copy this. Run the program again and paste our coded message. My name is Inigo Jones. Ta-da! This is exactly what we want. We are done with this program. So, again, my name is Don the Coder, and we'll see you next time. Happy coding to you.